Hello, everyone. You are welcome to today's lesson. And today's lesson, we are going to, first of all, look at the solution to the assignment that was given in the previous lesson. That was lesson 2, okay, on the topic coordinate geometry 1. Okay, so the first assignment, which was a class assignment, that's exactly what we have here. We were to determine whether or not the lines, these three lines, okay, are concurrent. Okay, so at this point, okay, before you can confidently say that lines are concurrent, three or more lines, but I'm restricting or we restricted ourselves to three lines. Okay, before we can say that they are concurrent, then we know they should have a common point of intersection. So the concept is to take, okay, two different pairs, okay, of the lines with their equations, solve them simultaneously for the point of intersection. If you realize that you get the same point of intersection for, okay, the two pairs, okay, that you dealt with, then you can comfortably say that the lines are concurrent. Okay, so quickly, let's look at how I dealt with the question. Okay, yours might be different because it's possible you will pick different pairs to work with. However, we should all land at the same result. Don't forget this. So as usual, okay, the first thing that you write is solution. Is the question numbered? No. So it means your solution must not have any number. Okay, then after that, what do? You extract. So given, you can choose not to write the given. However, the three equations that you are given must be extracted. So I extracted the first equation, label it equation 1. Second equation, label it equation 2. And the third equation, label it equation 3. So you can see that I extracted in, okay, row. Usually you will extract in what? In column. So the first one will come here. The second one will be below it. The third one will equally be under the second one. So you should know that if you go that route, you are going to use three lines. But here is the case, we have to maximize the use of our page, okay, because in elective math now, we are looking at constraints, okay, space. So you have this in mind. It's better always to extract row-wise rather than column-wise. So take notes. Okay. Now at this point, okay, let's see. We need to take two equations and work on. So first two, then the second two. So let's study the equation and see the one that will be easy for you to work on because you are going to solve them simultaneously. If I look at equation 1, okay, equation 2, equation 3. It's only equation 1 that I have one of the coefficients of my unknowns being 1. Okay, the rest, if you take this, coefficient of x is 4, coefficient of y is 3. If you take this, coefficient of x is what? 5. Coefficient of what? Y is what? 4. So it means the pretty equation here will be equation 1. So once I have, okay, recognized or identified my pretty equation, what do? It means any pair that I will take, I have to involve this pretty equation. Remember, the young will know the rules. Okay, the elderly and the wise will always know the exceptions. So you think before you write, before you go and stress yourself. So, okay, I can take equation 1 and equation 2, then equation 1 and equation 3. Remember, I said any different pair that you take, your automatic or the equation that must be involved in that pair should be equation 1. Okay, that's not to say that you cannot work with equation 2 and equation 3. You can work with equation 2 and equation 3. However, using elimination or substitution method, okay, with these two equations will be a little involving. No one wants, so yes, it's good to be hardworking, but it's better to be smart. Okay, so we are going to work smarter rather than harder. All right, so at this point, okay, then I know I am going to work on equation 1 and equation 2. Okay, so if I look at equation 1 and 2, okay, if I want to use elimination, I have to multiply equation 1 by 3 because I can easily eliminate y. If I want to eliminate x, I have to multiply equation 1 by 2. But I don't want to use elimination, I want to use substitution. So by that, okay, I went for substitution because I realized that if I make y the subject here, it will not involve a fraction. And if I want to eliminate, I have to at least multiply one equation by a constant. So usually I will avoid that. If I could add or subtract directly to eliminate, then I would have gone for elimination. Okay, so this informed my decision for the substitution method. Okay, so if I want to go by the substitution method, then I have to make one of the variables the subject, but preferably, okay, y in equation 1. So I'll come and write from 1. Don't write equation, I've told you, this is from writing this. It's not universally accepted. Okay, so don't write this equation this way. 1. Just write one circle. Okay, it's regarded as an equation. That's as I've done here. So from 1, comma, so I'm going to make y the subject. So I'll maintain the y here because it's positive. Then move this one to this side. So that will give me 1 minus 2s. And I will label this as equation 1a. Okay, you can call it equation 4. But I usually, immediately I take one equation and work on it. I attach, letters for me to know that I took a particular equation to work on it. So that in case of any troubles, I can trace the parent. Okay, where and do the necessary editing. Okay, however, if you don't want to adapt and label this as equation 4, you can. Okay, that is what I do. If you want to adapt, you can equally adapt. So now, okay, I'm working on equation 1 and equation 2. So once I've made y the subject in equation 1, automatically I have to substitute that one into equation 2. So I will come and write equation 1a into equation 2. And surprisingly, I've been saying this times without number, and I'm going to repeat it because some of you, I don't know whether your ears are hard or you are just being difficult. Okay, so remember I told you that don't write puts. Okay, if you want to write your English, then instead of put, write putting. Don't write substitutes. Instead of substitutes, write substituting. But I've told you, okay, it is not necessary. Just write the equation number that you want to substitute into the other equation. So equation 1a into equation 2. Okay, comma. Then, so it means I've told you again, this shouldn't take one line. It should always be too short to consume a line. So, comma, then come and do your substitution besides. So, ordinarily, this should have come down. So, what should have been here, you can bring it up here. So, I have 4x plus 3y. What is my y? Y minus 2x. Then plus 5 is equal to 0. I guess you can see the marks. I'm not mentioning them because, okay, you are expert in marking in terms of, okay, how to identify the marks. Okay, so that's why I'm a little silent on it. Okay, so at this point, what do? You come and expand. So you get 4x, then this time this will give you 3, this time this will give you minus 6s plus 5 is equal to 0. So at this point, this is what I'm going to do, or this is what I did. Okay, ordinarily, I should have written 4x minus 6x, which will give me minus 2x here, is equal to, then I will get 3 plus 5, which is what? 8. Okay, so then I will have minus 2x plus 8 is equal to 0. But you can see that I would want to write my positive first. So ordinarily it should have been 8 minus 2x is equal to 0, or minus 2x plus 8 is equal to 0. But I decided to show maturity here. Okay, so I kept my positive, okay, because the 8 will be positive and the x will be negative, the s term. So I'd rather move it to that side. That will make it positive. So that's how come I have 8 minus 2s there. So if you went through certain steps before getting this, okay, those steps will not warrant or get any marks. This is where your m half will be, where you get your equation this way. Either 2s is equal to 8 or minus 2x is equal to what? Minus 8. Okay, it's either these two equations that will give you this. In that case, if you had a negative situation, you would divide by negative. But for me, I'm going to divide, write it again and divide by positive. And that's what you can see obviously here. Okay, so after dividing by the 2, you will get x to be equal to 4. I will need to substitute x to find my y. So that should inform me that this x must be labeled. This equation must be labeled, I should say. So I will label this as equation 4. However, if you label this as equation 4, then this should be equation 5. So take note. Okay, so now what do? I will need to substitute equation 4 into the equation that y has is already the subject. So I will write equation 4 into equation 1a. I didn't write put, I didn't write putting, I didn't write substitute, I didn't write substituting. Not that I am lazy, but because I can do away with it and still establish the same point. So I will have 4 into 1a. So that will give me y is equal to 1 minus 2, x is 4. So into 4. Then that will give me y is equal to 1 minus 8, which will give me y to be equal to minus 7. I wouldn't substitute what? The y. So I wouldn't label it. I don't need it. Okay, so at this point, I know the x and y, so I know the point of intersection of what? The first line and the second line. So I'll write this implies that 4 minus 7. Be very careful. Okay, the x coordinate is 4, and the y coordinate is what? Minus 7. So make sure they take their usual positions. Okay, it's equal to point of intersection. And I cannot write therefore here because I was not asked to find the point of intersection. This is just a means to an end. So you can either ignore the implication or bring implication, but therefore no way. All right. Then you are going to take another pen. I've told you that before we started, I told you that we're going to work on equation 1 and 2, then 1 and 3. Okay, so if I'm solving equation 1 and 3 too, I will go for substitution. But here is the case. Thankfully, I have made y the subject here. So I know again that I need to go and substitute 1a into what? Equation 3. Okay, so straight away, I don't go and do my change of subject again. Okay, so because I've done that already. So I've reduced my work sort of. So 1a into equation 3, and that will be 5x plus 4y. Your y is 1 minus 2x, then plus 8 is equal to 0. Okay, so look at the marks there and assign the marks. So you get 5x plus, you remove the bracket here, 4 minus 8, x plus 8 is equal to 0. So again, just as I did here, I'm going to combine like terms and see whether my x term will be negative and I have to move. Okay, so this will be 5x minus 8x, and that will give you minus 3x. So it will be minus 3x plus 12. Okay, is equal to 0. So I will move the 3x to this side so that I'll get 12 is equal to, 3x. Is my point well made? Let me see if you are with me at this point.
Yes, please.
Okay, great. So what do? You write it again before you divide. You could have kept the 3x here, 12 here, written the same thing here. Okay, then divided by the 3. But I decided to write my s. That doesn't mean I moved. Please take note. If a is equal to b, then b is equal to a, principle that I used here. So that will give you s is equal to 4. Okay, at this point, s is equal to 4. This is the same as this equation. So someone can choose not to label this as equation 5. Because it's the same as equation 4, I can still call it 4. But I decided to call it what? Equation 5. So it means, equation 5 is equal to equation 4, basically. Okay, so at this point, if s is equal to 4, you need to substitute this. So equation 5 into the third equation, because we're working on equation 1 and 3. So into the third equation. So, sorry, we are looking for the what do you call it? The y. So once we know x, we have to substitute that one, forgive me, into this. Okay, because we need y. Okay, so now what do we do? Again, you know that if x is equal to 4, y will be equal to what? Minus 7. So you could have written the value there straight away because virtually it will be the same work. So just for explanation purposes, I wrote this. So y will be equal to 1 minus 2 into 4. So you can see that no marks for this because that work has been done here. We don't give marks, double for the same work. Okay, so y will be equal to minus 7. Okay, so this is what we have here. Okay, then at this point, again, you get your point of intersection, then you come and draw your conclusion. Because the point of intersection of the two pairs that you work on, gave you the same result, then your conclusion is that the lines are concurrent. Point well made, my professors. Any questions at this point? So I guess now you should all be able to mark. Okay, Prof. Della.
What if you substituted both?
You substituted?
Both equation 3 and 4 into both equation the values of x and y into equation 3, like at once.
No, I don't get you. Okay, so I'm trying to get your argument. So let me see whether indeed I tried. Okay, well, so this is it. You are trying to say that, okay, here you don't know. It's a good, but because it's a subjective question, okay, I wouldn't advise you deal with it that way. So you are saying that because that's what we use in terms of the application. So you were trying to apply that here, if I'm guessing right. So because this is a point of intersection, if this is a point of intersection, okay, of these two, then it means if you substitute the two values here, this must be true. If it is not true, then it means, okay, the lines are not what concurrent. Is that, you get my point? So I was able to, okay, am I in line with you?
Yes, please.
Okay, so it is allowed, but I would advise subjective wise, don't deal with it that way. Take one pair, find a point of intersection, take another pair, find a point of intersection, then come and draw your conclusion. But that analysis that you did, there is nothing wrong with that, because in any case, that is what we use. Remember, I told you that you use that one when the question is emphatic. Okay, is you know for sure that the lines are concurrent. But here we didn't know, okay, it could be concurrent or not. But in any case, if it is not concurrent, you know that it will not satisfy. So you don't have to come and what? If you substitute, this side will not be equal to this. Okay, but my point is well made. Okay, if it is subjective, don't use that route. Okay, unless
Yes.
maybe it's an objective question, and instead of going to solve that simultaneously, okay, you have the point of intersection, substitute. If it's satisfied, it means concurrent. If it doesn't, then it's not concurrent. Then you go and choose the right option.
Yes, please.
Is that clear, my professor?
Yes, please.
Okay, great. All right. So now this will be it for the first one, the class assignments. Okay, if you are all done with the marking, I guess I can move on to the second one. Can I? Okay, in any case, I will send the video after. Okay, so this was the second assignment. Okay, so quickly let's go and look at what the solution. Forgive me. All right, so the first one of the second, the first question one of the second assignment. If the points, so these are the 3 points, are collinear, find the values of t. So here you know the points are collinear. So it's not about you taking a pair, go and find, okay, the gradient, take another pair of points, find the gradient and compare. Okay, so with this one, you know automatically the gradient must be equal because they are concurrent. Okay, sorry, did I say concurrent? Lines are concurrent and points are collinear. Forgive me. Okay, so if they are collinear, remember the point didn't come with a name. We will know per experience, we will know our approach. Okay, so because of that, we will name or label the point. So we write okay, then give your points. The first point A. Okay, the second point, let it be B. The third point C, because we know the route that we want to go. So if that's the case, then but, and here, remember I said you take any two different pairs. It doesn't really matter on the pairs that you work on. Only that we said when I was introducing you to, we use the adjacents. But I told you, okay, going forward, I told you that it would not be necessary, or it is not necessary to take the adjacents. Just take two different pairs, that's all. But here, okay, so if I look at the pairs of the point that I have here, okay, it's only 1 point that has two, okay, a letter in the coordinates. The x coordinate contains a letter, y coordinate contains a letter. This one is only the x coordinate, this one is only the y coordinate. So it means these two will be the the pretty points. The point that any pair that you take, at least, okay, it must be involved, they should be involved. So I will go for A, okay, then what? Then B, then maybe A and C. Okay, so always, at least these 2 points should be involved. So if I take A and B, I'll find the gradient of AB. So that is denoted by MAB, and that must be equal to the gradient of A, the line joining AC, so AC, so MAC. That's what we have. Then look at the marks there. if you extract B half. Okay, so this condition, if you are able to state it, that will be B1. Okay, that is the major condition. This is the not. If you're able to get this, then we are good to go. Okay, most of you were able to do this, only that those of you wrote A, B, A, C, and some of you wrote A, B, then B, C. There is nothing wrong with that. Okay, there is nothing. You can pick any two different pairs like I've stated. Only that if you write A, B, B, C, or whatever, and I can't see A and B, A, B, C here, you know there is a missing link. That's why I said, anytime you write, don't just write. So even if you come and write this, at least, okay, if you are careful, you realize that, okay, I've mentioned A, B, A, C. Where is my A? Where is my B? So that should tell you that maybe you need to go and write let's then name, okay, your points. Or you can come down and write A is equal to this, B is equal to this before you go and substitute. Because we need to know the exact points representing A, B, and C so that we can really, okay, deal with or understand your presentation. Okay, like I said, this one, okay, the connection, okay, the gradient connecting the two pairs, okay, being equal, almost everyone got it right. The problem started when you were dealing with the algebra. Okay, and I don't know why, because I see this to be trivial, but still we are learning. Okay, so make sure the mistake that you did in your presentation, you won't do it again. So I am going to use A, B. So it means my initial point will be A, my terminal point will be B. So it means the coordinates of the A will be X1, Y1. The coordinates of the B will be S2, Y2. Okay, so that's what I'm going to do. So let's see. Okay, so my A, remember gradient is changing Y over changing X. So my Y2 is this. Let me write it on top so that you can easily relate. So X sub 1, Y sub 1, X sub 2, Y sub 2. But as you mature, you can do it mentally without doing this. So that's what I did. So my Y sub 2, because it will be Y sub 2, gradient is Y sub 2 minus Y sub 1 over S sub 2 minus, okay, S sub 1. Or, okay, Y sub 1 minus Y sub 2. If you write it this way, then you need to write this one as also as S sub 1, okay, minus X sub 2. Remember, the corresponding should be. So in this case, I am using the first one. So Y sub 2 is T minus 3. Ordinarily, it should have been in bracket, but because I am matured, I know that it's going to multiply 1. The bracket wouldn't be necessary. Okay, then minus your Y sub 1. Y sub 1 is 3. Okay, so like I said, if you like, you can put it in bracket. Just for, I've told you, anytime you are substituting something, ideally, okay, for you to play it safe, put it in brackets. And because some of you didn't adhere to this advice, okay, you got stranded from here. Okay, meaning you lost, okay, the marks there. So simple advice, please take notes. Play it safe rather than to show maturity. All right. So now what do we have? Over my S sub 2 minus S sub 1. Okay, so S sub 2 is T. S sub 1 is what? T minus 6. So with this one, if you fail to put it in brackets, you are doomed, which some of you did. Okay, because I've told you, anytime a binomial comes after a minus, strictly it should be in brackets. But even if you didn't hit to that and you just went by the major advice, always substitute, put your substitution in brackets. So it means ordinarily this should have been in brackets. Okay, this should have been in brackets. This should have been in brackets, and this should have been in brackets as well. In that case, you are safe. But like I said, I decided to deal with it maturely, because I will know where the brackets will be necessary and where it is not necessary, because I am matured. Okay, so at this point, I come to my gradient of AC. So AC. So my Y2 will be this. Okay, my S2 will be what I have here. So it will be T minus 1. If you like, you can put it in brackets. I decided not to because, okay, before that, it will be plus 1. Then minus my Y, okay, sub what 1, and that is 3. All over, okay, my X sub 2, which is minus 1, then minus X sub what 1, which is this. Again, I put it in brackets. Failure to do that will be costly. So if this is not in brackets, any of these two not in brackets will be M0. You've lost your way. If you get your answer going forward, or you get to do the right thing going forward, you are now doing maths. Sorry, magic, not maths. Please take note. So at this point, I know I can come and simplify. So let me clear what I introduced just to explain. So let me take it off. Okay, I introduced the brackets here, which I said as you mature, it's not necessary. But you can play it safe, okay, by introducing anytime you are substituting. This one cannot go. Okay, so I've taken care of the bracket that can go. So at this point, I know numerator, denominator can be simplified. So I go and simplify the numerator. It will be t minus 3 minus 3. So that will give me minus 6 all over. I come and remove the bracket. Minus t plus 6. So that was what I have here. It's equal to, this one will give you t minus 1 minus 3. So it will give me minus 4 over minus 1. This time this will give me minus t. This time this will give me plus 6. Okay, after I've removed the brackets, combine like terms, but I can see that I still have like terms in my denominators here. So t minus 6 already simplified numerator. This one, the t and the t will go, so I'll be left with 6. T minus 4 numerator, I can't do anything to it. This one, I can. It will give me minus 1 plus 6. That will give me 5 minus t. Okay, so at this point, I cross multiply, but I don't use my line to show the cross multiplication or indicate the cross multiplication. So it will be t minus 6 times 5 minus t. Each of them must be in brackets because your quantities there are more than a monomial. Failure to do that will be costly. It's equal to, okay, this is a monomial, bracket is not necessary. This is a binomial, you put it in bracket, remember. Okay, that's not to say that if you put this in bracket, you are wrong. So you can equally put it in bracket, only that it will not be necessary. Okay, so at this point, what do? We come and expand. So if you expand the side, we are going to get this time this, which is 5t. This time this will give us minus t squared. This time this will give us minus 30. This time this will give us plus 6t. Then you come and expand this one to 6t, okay, minus what? 24. Okay, so that will be M1. Then after that, I combine like terms here. But in combining like terms, I realize that there is a 6t here and 6t here. So I should know by maturity that they will cancel. So when I'm combining the like terms, okay, so it's like I cancel this. Let me put it that way. Okay, I canceled this. So when I canceled this, I ended up getting this. Okay, so you can see that there is no max here. So meaning when you are mature, you can move from here to here. Okay, and what I have here is basically for explanation purposes. Because if I move from here to here straight away, some of you might not understand what I did. You'll be confused. So in this case, I cancel this and this because each side positive 6t, positive 6t. So if you move, they will cancel out. So it will be left with this one here and this one on this side. So there's a quadratic equation, obviously, in t. Okay, but your t squared term is negative. So when you are moving, you use the t squared term, okay, to move. But because my t squared term is negative, it means I have to move the t squared to the side. In my mind, I'm moving everything to this side, but I will write it here. Okay, so it will be this one moved to this side will give me positive t squared. Then I will get this one will move this one to this side, which will give me minus 5t if this one comes here. Then this one will be minus 24. This one will come here and give me plus 30. So it will give me plus 6. Minus 24 plus 30 or 30 minus 24 will give me positive 6 is equal to 0. I guess my point is well made, my professors.
Yes, please.
Okay, great. So now at this point, what do? I know I will get this equation. And thankfully, the leading coefficient is what? Is 1. Once the leading coefficient is 1, okay, you concentrate on this, or you can factorize straight away without going through the factorization by grouping. Okay, because this is a special situation. I remember I told you, get your 2 brackets there. So this is how indicate your 2 brackets because you are going to get this. The first one will be t, second one will be t. Get the factor pair of what? Of 6. That's when you multiply, you get 6. When you add, you get minus 5. And that will be minus 2, minus 3. Then you just come and attach minus 2, minus 3. You are done with your factorization. It's equal to 0 for the special situation. Okay, so it's equal to 0. Now, this step is very critical, where you set each of them to 0. So t minus 2 is equal to 0, or t minus 3 is equal to 0. If this connector is not there, or you bring a comma, you forfeit, okay, the m mark here. you get M0. Be careful. I've warned you before or advised you before. So at this point, I come and solve for t. So t will be equal to 2 here. If I move, t will be equal to 3. What was I asked to find? I was asked to find the values of t. So now that I have the values, I draw my conclusion. Therefore, t is equal to 2 or 3. And again, the difficult ones, please, I'm talking to you. I've told you, anytime the question asks you to find value or values of anything, don't write therefore the value of. Just write the quantity that you are asked to find its value. Write the quantity and write equal to and attach the values. That's all. Don't write therefore the values are, this, I've told you, it's not necessary. Just conclude by writing this. I wrote this not because I'm lazy, but because, I want to work smarter, and still protect my marks. So that will be it for question 1 of the second assignment. Now, quickly, let's come to question 2. Or before question 2, any questions? So you are fine. And like I said, most of you, you were exposed. It's your algebra that exposed you. So at this point now, let's look at question 2 if you're okay with the question 1. And the total mark here will be, will be 10. Marks will be 10. So now let's come to the question 2. Find the value of P. So we are asked to find the value of P. So we won't conclude by saying therefore the value of P, no. If the lines, are concurrent, so we know the lines are concurrent. If you like, you can underline this one. This one too, if you like, you can underline this. So given you extract your 3 lines, remember, if the lines are concurrent, then they should have a common, point of what? Contact. But you can see that it's only these 2 equations that you can solve easily simultaneously for the x coordinate giving you a value and the y coordinate also a value. So we are going to work on equation 1 and equation 2. When you get your x and y value, remember, you come and substitute because it must satisfy this. You substitute and you solve for P. So that was so if I look at this, when I listened to the 2 equations, the equations told me that I can go my usual way, elimination, because the coefficient here is 1, coefficient here is also 1. So I can subtract to eliminate. So it's either I subtract equation 1 from 2 or 2 from 1. However, I did 1 from 2. So I wrote equation 2 minus equation 1, comma. So it means I'm going to do my subtraction x minus x, and that will go. X will vanish. That was my intention. I was eliminating x, and indeed, x has been eliminated. Then I'll get 2y minus y. So it will be 2y plus y, and that will give me 3y. Then I will get minus 8 minus 1. So it will be minus 8 plus 1, which will give me minus 7 is equal to 0. I can solve for y here because it's a linear equation in y. I move the minus 7 to the side, which will give me positive 7. I write it again before dividing, and I will get y is equal to 4. I cannot conclude with y. I was not asked to find y. So y is only a means to an end. I need the x and the y to substitute. So once I know y, I can go and find x. So I label this because I will use it as equation 4. Then go and substitute equation 4 into any of the 2 equations that we were solving or I was solving. And preferably equation 1 because it involves smaller values. So I did equation 4 into equation 1, and that will give me x minus 7 on 3 minus 1 is equal to 0. And you can see that here I didn't change it to mixed numbers because I'm not concluding with it. Even if I change and I'm going to substitute, remember I've told you, avoid substituting mixed numbers. Instead, substitute it corresponding improper. So I left it in the improper and substituted as such. So at this point, we can always do this mentally. Or you can still use your calculator to combine the like terms here. I know some of you will clear the fraction, multiply through by what have you. This is relative math. So don't worry, you can use your calculators as much as possible. So x minus, I did it mentally because I know that this will give me minus 2 whole number. 1 on 3. Am I right? Only this one.
Yes.
Then minus 1. So I know that this will give me minus 3 whole number 1 on 3. And if I change this one to its corresponding improper, I will get this time this, which is minus 9 plus this. So that will give me minus 10 over what? Over 3. Okay, so that gave me this. I did it mentally. But like I said, you can use your calculator as well. It's equal to 0. Then I will move this one to this side, and that will give me this. Okay, this time around, I'm going to label this as equation 5. Okay, because I will need it. I will need to substitute that into this, the equation 3. So I write equation 4 and equation 5 into equation 3. So wherever I see x and y, I substitute the corresponding values. So it will give me 10 over 3 plus p. My y, okay, is 7 on 3 plus 3 is equal to 0. So obviously my LCM will be 3. So I will multiply through by 3. Or you can go ahead and remove the bracket, but that will give you 10 over 3 plus 7p over 3 plus 3 is equal to 0. So you still have your LCM to be 3. So I'll multiply through by the LCM. Because one of the sides of this relation contains more than a term, I can do my multiplication mentally. So 3 times this, the 3 will cancel, I will get 10. 3 times this, the 3 will cancel, I will get p times 7, which will give me 7p. 3 times this will give me 9 is equal to 0. Then now what do? I'm looking for p. So I combine this, which will give me 19, move it to the side. That will give me minus 19. Write it again before I divide. And you remember, you cannot conclude with what? Ordinarily, there should have been a step here, but you can skip that step, which will be p is equal to minus 19 on what? On 7. But you cannot conclude with that. Remember, you avoid concluding with an improper fraction unless otherwise stated. So therefore, p will be equal to, you change this one to its corresponding base numbers, and that will give you minus 2 whole number 5 on 7. And that will give you A2. So in all, for the second assignment, okay, the total marks will be 19 plus 1 bonus. So making everything 20. Okay, so the bonus mark, this is how if you scored 18, okay, to 19, that's where you get your bonus mark of plus 1. Anything below, even if it's 17.5, you will still not get the plus 1 bonus. Point well made.
Yes, please.
Okay, is everyone fine, my professors? Okay, so on this note, this brings us, okay, to the end of what the discussion and the marking of what the assignment. Okay, so once again, thank you for your time and your contributions. Okay, and God bless us all.